Okay, here we go. So this presentation today will be about dredging technology. I will give you an insight into the world of dredging. What you see on this screen is La Draga. La Draga is a drawing from Leonardo da Vinci. This is about the oldest drawing you can find of a dredger. It's quite ingenious. And I'm a very big fan of Leonardo da Vinci because he was not only an engineer, he was also an artist, which is quite unique. A small disclaimer. I believe that all these materials used in this presentation are free of copyrights. I am also not promoting one or the other company or the company I'm working for. You will see that all the pictures and videos are from different companies. You see here the dredger Crestway during his sea trials, trying out the rainbow installation. Myself, my name is Luc Verley. I work more than 25 years in the dredging industry. Probably when you cut open my veins, you will find sand. There's no blood in my veins. I have also worked as a marine surveyor for Touw Holdings in Rotterdam. That's where my connection is with IIMS. I also followed the IIMS diploma course for marine surveyor. On the pictures you see me, the picture below you see me in 1974 on a beach in Palma de Mallorca. This is probably my first dredging project, where I discovered if you mix sand and water, you can do amazing things with it. The picture above is me as a young guy, as an engineer on board of a dredger in the Niger Delta in Nigeria. This is the agenda for today. We will talk about what is dredging, why do we do dredging, who are the players in this industry. We will look at some very big dredging projects. We will look at 3 types of dredging equipment. This is the most common dredging equipment. That's the trailing suction hopper dredger, the cutter suction dredger, and the Baku dredger. We will have a look at the future of dredging. We will have a look at the role of the marine surveyor in dredging. And at the end, we have a question and answer session. What you see here is an extract from Wikipedia. Now, Wikipedia can normally not be used in an academic presentation, but I still do this since I contributed to this description of dredging. And this is probably the most complete description of dredging. So dredging is an excavation activity or operation usually carried out at least partly underwater in shallow seas or freshwater areas with the purpose of gathering up bottom sediments and disposing them off at a different location. This technique is often used to keep waterways navigable. It is also used as a way to replenish sand on some public beaches where too much sand has been lost because of coastal erosion. A dredge is a device for scraping off or sucking the seabed used for dredging. A dredger is a ship or boat equipped with a dredge. The terms are sometimes interchanged. We will talk in this presentation the whole time about a dredger. The process of dredging creates spoils, excess material, which are carried away from the dredged area. Dredging can produce materials for land reclamation or other purposes, usually construction related. It has also historically played a significant role in gold mining. Dredging can create disturbances in aquatic ecosystems, often with adverse impacts. This last part, there's no way. The dredging has a very big impact on the ecosystems. We will use machines, we will scrape the bottom of the seabed. Make yourself no illusion, a dredger has a very, very big impact on the ecosystems. There are environmental studies made prior to dredging projects, but the impact is very big. What is sand? That's a very good question. It's not a straightforward question to answer. Michael Welland has written a book about sand, and his definition of sand is that sand is a granular material that is defined purely by size, got nothing to do with what it is made of. It is bigger than silt and mud. It is smaller than gravel and pebbles. Sand can be made of corals, shells, lava, quartz, anything between 0.06 millimeter and 2 millimeters in diameter. So most important to remember from this is that sand is not defined by the material it is made of, but purely by its size. I also want to explain that a dredging company is not a shipping company. This is a mistake that is often made. Many people think a dredging company is a shipping company. We have nothing to do with shipping companies. Yes, we comply with all the IMO pillars, SOLAS, MARPOL, STCW, MLC, because we use floating equipment, but we are a construction company. It's very important to remember that is a mistake that is often made. We look now at why we do dredging. These are the 5 reasons why we do dredging. We do maintenance dredging. This is a continuous operation to keep existing waterways and harbors open to navigation. You need to do maintenance because due to the tidal movements, the wave, the currents, there will be erosion in the navigation channels, so they need to be maintained. Second part is capital dredging. Capital dredging is civil engineering works, building new channels and land reclamation projects. It's all infrastructural works. Mineral and aggregate dredging. This is the extraction of underwater deposits, such as gravel and also gold. Gravel is well practiced in the UK, whereby gravel is taken from the seabed, which is used for the concrete industry. Gold is done in Namibia and South Africa, where very big dredgers are dredging the seabed and they are filtering out the gold deposits. Environmental dredging. Environmental dredging is removal of polluted soil on the seabed, polluted soil from heavy industries. This material will be dredged and will be cleaned. The last one is offshore dredging. Offshore dredging is done for the oil and gas industry, mainly dredging of trenches where pipes will be laid in, and landfalls where the pipes will, gas pipes or oil pipes will go to the shore. The pictures you see below are quite interesting. The picture on the right-hand side is the access channel to the port of Miami, which was made deeper to allow big cruise liners to go into the port of Miami. And you can see exactly where the channel is dredged. It is, you can see it in the difference in the water color. And the picture on the other side is a sand motor. A sand motor is an experimental project to create a dynamic coastline. This is a man-made sandbank, which is about 1 square kilometer. And over the years, the idea is that this sand will be moved by the tidal movements, by the waves and the currents, and will deposit itself onto the beaches. They hope that this is a more economic method and a less disruptive method to reinstate the beaches. This project is taking place in the Netherlands. We now look at the players in the dredging industry. I call them the Fantastic Four. These are 4 companies. See there, Boskalis, a company founded in 1910, headquarters in Papendrecht in the Netherlands. We see DEME, that is a company founded in 1991, is also known as Dredging International. The history of this company dates back till 1852. Its headquarters is in Zwijndrecht, near Antwerp, in Belgium. Then you have Jan de Nul, a company founded in 1938, has dredging activities since 1951. This is the youngest dredging company. Its origin is Belgium. Its headquarters is in Luxembourg. And then you have Van Oort, another Dutch company based in Rotterdam in the Netherlands, founded since 1868. These are 4 companies that control 60% of the market. 60% of all the dredging projects in the open market are controlled by these 4 companies. As you can see, these are 2 companies from the Netherlands and 2 companies from Belgium. There's a very good reason for that. As you will know, the Netherlands, half of the country lies below 1 meter above sea level. And 1/8 of the country is actually below sea level. That's the area that is marked in the dark blue color. The Netherlands exists out an extensive network of dams and dikes and dunes to protect the country from flooding. Floodgates and storm surges and pumping stations are all over the Netherlands. That's where the experience comes from of all these big infrastructural waterworks in the Netherlands. Belgium. Belgium has a port which is called Antwerp. It's the 3rd largest port in Europe after Rotterdam and Hamburg. This port is actually started in 1811 by Napoleon Bonaparte, who created the first dock. This dock is still existing. And the River Scheldt is open to navigations for ships of more than 100,000 gross registered tonnage. These ships have to travel from sea to the port of Antwerp over the River Scheldt, and they cover a distance of about 80 kilometers. This river requires continuous dredging because of the high tidal movement and the currents. There is continuous dredging going on this river. This is where the expertise comes in from the Belgian companies. Then the new kids on the block. The new kids on the block are China and India. Up till now, both China and India use their dredging fleets mainly for their home markets. The Chinese have the biggest dredging fleet in the world. The Chinese have now merged all their dredging companies into CCCC dredging group of companies. China has also carried out the controversial land reclamation works in the South Chinese Sea on the Sparty Islands. You can see the picture there with all the dredgers reclaiming land. China will also construct the Nicaragua Channel, a channel that will compete with the Panama Canal. A crucial role in dredging project is the financing of dredging projects, and the Asian Infrastructure and Investment Bank plays a very important role for the Chinese, whereby the Chinese are financing the projects. We're now going to look at some dredging projects. We will look at 4 different projects, very big projects. This will give you an idea of the large scale of dredging activities. The first project is a very recent one. It is the Suez Canal in Egypt. In 2014-2015, there was a second Suez Canal of 35 kilometers long, constructed next to the existing channel. This channel is 147 meters wide. Is 147 meters wide and 24 meters deep. 250 million cubic meters of sand have been dredged in a period of 10 months. 21 cutter dredgers were deployed and 5 hopper dredgers. 80 kilometers of pipelines were used to transport the sand that was dredged. There were dredging volumes reached of 1.4 million cubic meters of sand per day. We call this the Olympic Games of dredging. Next project is Hong Kong International Airport. Hong Kong International Airport was built on a large artificial island formed by leveling the island Shep Lap Kok. A 9.3 38 square kilometer island was created in a period of 2.5 years. The airport site of Hong Kong is equal to 1% of Hong Kong's total land surface. It's one of the biggest earth-moving exercises in the world, by as well dry earth-moving equipment and dredging equipment. 15 trailing suction hopper dredgers, 5 cutter suction dredgers, and 7 grab dredgers were deployed in a joint venture to create Hong Kong International Airport. There is currently another tender running for the expansion of the airport and to reclaim another 650 hectares for a third runway. Singapore, that's where I'm talking from to you. Singapore expanded the size of the country since its independence in 1965 with 24%, from the original 580 square kilometers till 720 square kilometers. The original size of Singapore you can see in the gray color, and all the light red color is reclaimed land. Singapore will still expand another 10%, that is the dark red color you see, another 10% with an additional 66 square kilometers by the year 2030. Singapore is the largest importer of sand in the world. Its neighbors Malaysia and Indonesia have actually banned the exports of sand to Singapore. Sand supply is now done over long distances. Sand is coming from Cambodia and Vietnam. The picture you see of the dredger is the Vasco da Gama. This was the very first mega dredger that was built. And this vessel has really played a crucial role in the reclamation of Tuas and Jorong in around the year 2000. The next one is the United Arab Emirates, the Palm Islands. I think most of you have heard of them. Palm Jumeirah is the one that you see on the smaller one on the right-hand side, is an artificial archipelago of 560 hectares. This Palm Island is protected by a crescent-shaped breakwater of 11 kilometers in length and has a width of 200 meters. The land reclamation for the Palm Island, Palm Jumeirah, started in 2001 and was completed in 2004. It is the world's largest man-made island. 110 million cubic meters of sand were dredged for these reclamation projects. Currently, it accommodates 4,000 houses and 28 hotels. The cost price to build Palm Jumeirah is estimated at $12 billion US, and that's only for the dredging works. Palm Jebel Ali, the one more to the west, is a project that started in October 2002. The land reclamation is completed with 300 million cubic meters of sand. The breakwater was completed in December 2006. It is 15 kilometers long and 200 meters wide. And there is the World. The World is the project you see on the east side of Palm Jumeirah. The World is an artificial archipelago made out of various small islands constructed in a rough shape of the world map. It is located in the waters of the Persian Gulf, 4 kilometers off the coast of Dubai. The construction started in 2003, but was stopped in 2008 due to the financial crisis. The reclamation volume of the World is 325 million cubic meters of sand. We're now going to look at dredging equipment. You see a picture here of different types of dredging equipment. These are not the types of equipment we will talk about. This is just to show you that there is a huge variety of dredging equipment. We can see here an underwater bulldozer, we can see a grab dredge, clamshell dredge, a bucket wheel dredge, a mass flow dredger, a water injection dredger. In the left bottom corner, you can see a diamond dredger. Next to it is a pelican dredger. So these are all different. There's many types of dredging equipment, but we will focus ourselves on the three most important types of dredgers. And these three types are the trailing suction hopper dredger, the cutter suction dredger, and the Baku dredger. Dredgers can be classified in two important groups. That are the hydraulic dredgers, whereby water is used as a medium to transport the sand. And there are the purely mechanical dredgers. So a Baku dredger is a mechanical dredger. A trailing suction hopper dredger and a cutter dredger are both classified as a hydraulic dredger. Later on, I will explain to you how this works. These hydraulic dredgers works with centrifugal pumps. These are big pumps, very big pumps, and I will show you a few videos to explain you the working principle of these pumps. And now it seems to be that my video is not working. Okay, one moment. One second, we will start the presentation again. One moment.
The slurry enters the centrifugal pump through the eye of the impeller. The rotating impeller creates a centrifugal force which throws the slurry outward. The slurry develops a high speed as it travels between the blades of the impeller towards the edge. In the casing, the high-speed energy of the slurry is converted into pressure energy.
So basically what we do is, as I explained, we use water as a medium to transport the sand. So we'll use about 60% water and 40% sand. It's very difficult to visualize this, but I have a video here and it's quite unique because normally the visibility on the water is basically zero. But this video shows a pump, which is, they call it a semi-submersible pump. It's the same, it's a dredge pump and it is used to make a trench. And here you can actually see how it works. So you can see the pump here. This is the pump housing, same as here. And the pump is sucking up the sand, and you can see the channel that it is creating into the seabed. You can see the enormous force that this pump is using to suck up the sand. And you can see that it is a mixture of water and sand. And you have to try to get a production which is, of course, to take as much sand as possible. This is quite unique because normally it's impossible to have a visibility on the water when dredging works are taking place. You can see how deep this is going down into the seabed. It goes very fast. Why do we do this with this pumping of water and sand? Because of production. We can get incredibly high production rates with this. You can see the sand actually flowing towards the pump. Before we look at each individual type of dredger, let me first explain something about how many dredgers there actually are in the world. The world dredging fleet exists currently out of 1,468 active units. These are 37% of them are trailing suction hopper dredgers, about 546 units. 34% of cutter suction dredgers, 493 units, 80% of backhoe dredgers and also grab dredgers, 263 units, and 11% of other types of dredgers. Now, if you look at the world merchant fleet, there are 16,916 bulk carriers operating worldwide. There are 10,696 general cargo vessels. There are 6,971 crude oil tankers. There are roughly 5,000 container vessels and also about 5,000 chemical tankers, ro-ro and passenger vessels, around 4,000 ships. So the dredging industry is really a niche market in the marine industry. Okay, we look now at the trailing suction hopper dredger. Trailing suction hopper dredger is the workhorse of the dredging industry. Especially in the last 15 years, it started playing a more and more important role due to the technical advancements that are made, and also because it became more and more difficult to find sand close to the shore. These vessels have an incredibly high production. I'm going to show you a video now that shows you the working principle of a trailing suction hopper dredger. So you see here the dredger lowering the pipe to the seabed. Basically, these are huge vacuum cleaners. So the pipe is lowered to the seabed. So you can see here the drag head is going onto the seabed. The drag head is dragged over the seabed, and the material that is scraped from the seabed is sucked up by the pumps. So you see the sand here going into the suction tube. The pump is here placed onto the suction line and is driven by an electromotor. And the sand is then loaded into the hopper. The hopper is the holding area of the vessel. It's like a cargo hold on a merchant ship. There is all the sand water mixture is dumped in the hopper. then we will separate the water from the sand, because we only want to transport the sand. We do not want to transport the water. You see here the dredge operator. And this is how the water is removed from the sand. It's basically a huge funnel. The sand is heavier and falls to the bottom of the hopper, and the water flows back overboard. So at the end of the dredging process, we have a loaded hopper with basically dry sand inside. When we reach down the reclamation area, we have to get the sand out of the hopper. Therefore, we have to unload the hopper. That means we have to inject water into the sand to liquefy it again so that it becomes pumpable. We can pump it down through a floating pipeline to the shore. This is what the dredger is doing now. So through a floating pipeline, the sand is pumped to the reclamation area. We call that the sand field. And there again, the water will flow away and the sand remains there. So here you see that what is coming out is a water-sand mixture. The sand will settle down, the water will flow away. You see here a floating pipeline, and this is a pontoon that will spread the sand out. This is the rainbow method. This is the most spectacular method. So basically, again, this sand water mixture is pumped through a rainbow nozzle at the bow of the ship. And the last method is dumping by bottom doors. In the bottom of the ship there are doors. These doors will open and the sand will fall out by gravity. We will inject additional water to make it go faster, but it's basically by gravity that the sand is dumped onto the seabed. These are three methods whereby we can discharge a trailing suction hopper dredger. Okay, we look at the different parts. This is the drag head. The drag head that is basically like the head on your vacuum cleaner. It will touch the seabed, and the material is basically scraped, and then the sand will be sucked up through the suction tube and will go into the hopper, the loading area, the cargo hold of the vessel. This is done by a pump which is placed inboard. You see the pump here. The pump is placed in the engine room. It's always a separate room. It's called the pump room. And then the sand will be pumped into the hopper. And in the hopper there are overflows. Here you can see an overflow. And this overflow will make the water to flow overboard again and the sand to settle down. If we want to remove the sand from the hopper, we can do that through the bottom doors, which are visible here in the bottom. Or we can pump the sand, we can liquefy it again and pump it with our pump and go through the rainbow nozzle or connect it to a pipeline, a floating pipeline, to the bow coupling of the vessel. See another dredger that is currently rainbowing. So see the material coming out of the rainbow nozzle. You can see here also the bow coupling to connect to the floating pipeline. And we here see the suction tube in the rest position, because that is only used for dredging up the material. This is a smaller dredger. Sizes of these dredgers. They are coming in all possible sizes. I have divided them in 5 groups, as the small ones are below 4,000 cubic meter hopper capacity. The one you see here is a Russian trailing suction hopper dredger with a capacity of 2,700 cubic meters. This vessel is used for maintenance dredging. The medium-sized vessels are 4,000 to 8,000 cubic meters. The large dredgers are 8,000 to 15,000 cubic meters. The jumbo dredgers are 15,000 to 30,000 cubic meters. And you see here a picture of the Inai Kenaga, which is a 30,000 cubic meter hopper dredger. And the mega dredgers have loading capacities bigger than 30,000 cubic meters. The biggest trailing suction hopper dredger is currently, it are two vessels, the Leif Eriksson and the Cristobal Colom. They have a loading capacity of 46,000 cubic meters. Then we go to the second type of vessel, which is the cutter suction dredger. This is probably the most complicated one. It's quite difficult process. Nowadays, they are mainly used for the dredging of hard materials. Before, they were commonly used for land reclamation, especially in the Middle East. But nowadays, they are mainly used for dredging of harder materials. The trailing suction hopper dredgers have taken over a lot of the work from the cutter suction dredgers. We're going to watch again a video how the working principle is. And the video doesn't work again. Strange. My apologies again. It still doesn't work. Okay, I think the video is not working. I don't know why. I tried it so many times. I will explain the working principle on the picture. I'm sorry for that. So we see here the dredger. There is a cutter head in the front. This cutter head will rotate. It is driven by an electromotor or a hydromotor. There are teeth, pick points we call them, on this cutter head. This is mounted onto the ladder, which is this part. and the ladder is lowered down by means of a winch and is lowered down onto the seabed. The vessel is equipped with spuds. You see them here. There's an auxiliary spud and a main spud. Basically, they create a kind of fixed point to the seabed, and then two anchors will be placed on starboard and port side, and the vessel will basically rotate from the port side to the starboard side and back to the port side, swiveling around this spud, which is on the ground, while the cutter head is cutting the sand, and a sand pump in here will pump the sand through a pipeline and coming here over the back, and is then connected to a floating pipeline and will go to the sand field area. There are two spuds so that the dredger can make a walking movement to walk forward, so it's a stationary dredger. It is fixed onto the ground, and it will walk forward, and at the same time it will be swinging to the left and the right, cutting the sand, and that's basically how it works. I will show you another. No, my video doesn't work. I'm sorry for that. Here we see again a picture of the dredger. You see here the drag head. The cutter head with all the pick points on it. The suction mouth, which is partly mounted into the cutter head, cuts the soil. This is connected to a suction pump, which is placed here. The ladder is here now lowered. The cutter head is into the soil. It will cut the soil. The pump will suck up the water sand mixture. It will go through the pipelines, and it will go into another one or two pumps, which are called pressure pumps. So you have a suction pump and one or two pressure pumps, which then will pump the material over the pipeline that runs over the deck through a swivel bend connected to a floating pipeline and pumped to the shore. Here we see the two spud pillars, auxiliary spud, main spud, and this is like walking. The vessel is like walking forward, and always pushing the cutter head into the new layer of soil that will be dredged by swinging the dredger on two anchors. See here a smaller dredger. Again, the ladder is here, cutter head in the front. We see here anchor booms. These anchor booms, as you can see on this picture here, they are used to, once we make a forward movement with the dredger, we have to reposition the anchors. So these anchor booms will be used to lift up the anchors and bring them forward again. Again here, the two spuds, auxiliary spud and main spud, and a swivel bend on the end where the floating pipeline will be connected to. I hope it explains a bit how the cutter suction dredger works. The video was probably more visual, but it's not working. Cutter dredgers, again, are defined in 5 different groups. The small ones are, okay, this is a very good point, is how to define the size of a cutter suction dredger. I think there are many people who have different opinions about it. I always look at installed horsepower. Other people feel that it should be the dredging depth or the discharge pipe diameter. Some people feel that it should be the cutter power. I always used the installed power to define the size of the dredger. Small dredgers are considered below 3000 kilowatts. We see here a very small dredger from the IHC Beaver series. Medium-sized dredgers between 3000 and 9000 kilowatts. The large one, 9 to 13,000. The heavy-duty, 13,000 to 23,000. We see here the Zheng He, which is a heavy-duty dredger working in the Suez Canal. And the mega cutter suction dredgers are more than 23,000 kilowatt installed power. We go to the third type of dredger, which is the Baku dredger. The Baku dredger is a mechanical dredge. So the previous two dredges were hydraulic dredgers. The Baku dredger is a mechanical dredge. This is the most simplest one to understand. Everybody knows excavators. We see them many times on the roadsides. It's mounted on a pontoon. They're only a bit bigger in size. This is a really low-cost dredger. The capital expenditure is very small in comparison to the trailing suction hopper and to the cutter suction dredger. And the OPEX, the operational expenditure, is also low, especially if you compare it to a cutter suction dredger. Most of the times, these vessels are operated by only 4 crew members. And this video also doesn't work. These vessels, they actually operate backwards. So the dredge direction is backwards. Basically, the machine is digging the soil. It's an excavator. It exists. It's the same as a land excavator. It exists out of a boom and a stick, and there is a bucket mounted at the end. It's operated by hydraulics. There is a very big turntable which makes the machine to swing left and right, and the dredger is on three spuds. There are 2 fixed spuds, and there is 1 movable spud. So how this vessel moves is it actually lifts itself a little bit out of the water so that there is basically no buoyancy. So you get a very stable platform to operate from. The movement of the dredger is purely done by the spuds. The aft spud, the single spud, is a spud that can move on a carriage. So when the dredger has finished the dredging at this area, the vessel will lower the fixed spuds, and the movable spud, which remains onto the seabed, will move the dredger backwards. Then they will lower the 2 fixed spuds to the seabed again, and the dredger starts the next cycle of dredging. We can see here a dredger. This is a dredger from Finland, and you can see the 2 fixed spuds, and here the movable spud. This spud is actually tilting, and when the spud remains onto the seabed and tilts, the dredger will move backwards. You can see here that they are loading it into what we call split hopper barge. So the material is digged from the seabed and dumped into this split hopper barge. This split hopper barge will then, once fully loaded, sail away and dump the sand somewhere. These dredgers are mainly used for maintenance dredging works. You can see here the different parts of the excavator boom. You see the boom with the hydraulic cylinders, the stick with the hydraulic cylinders, and the bucket with the hydraulic cylinders. Again, these machines are coming in. First, this is a split hopper barge. So what is a split hopper barge? A split hopper barge is basically 2 ships, 2 half ships that are built together with big hinges. And there is a hydraulic cylinder in the bottom that will push the 2 ships' halves away from each other, and then the material dumps out by gravity. Very, very simple, very, very basic, easy to visualize. These dredgers, they also come in many sizes. You can see a very, very small one here. This is basically just a land excavator which they placed onto a pontoon. How do we define the sizes of these dredgers? That's by the bucket size. So the small ones are 1 to 3 cubic meters in bucket size. The medium ones are 2 to 8 cubic meters in bucket size. And the large ones are 8 to 20 cubic meters in bucket size. Then we have the mega Pacu dredgers, and you see here the Goliath. They can take bucket sizes up to 40 cubic meters. These are really very, very huge machines. You can see also the comparison to the car. Okay, dredging equipment. What does it actually cost? In order to make it better understandable, I compare bulk carrier. You see here the Vale Sohar. Vale bulk carriers are among the biggest bulk carriers in the world. These vessels have a dead weight of 400,315, are 360 meters in length, and are 65 meters wide. These are huge vessels. We see here the biggest trailing suction hopper dredger in the world, Cristobal Colon, a sister vessel of the Life Ericsson. This vessel is 78,500 deadweight tons, 223 meters in length, and has a width of 41 meters. Obviously, a much smaller vessel than the huge Vale bulk carrier. Now, if you want to buy this bulk carrier, it will cost you 60 million euros. If you want to buy this trailing suction hopper dredger, it costs more than 200 million euros. This dredging equipment is very, very expensive because of the huge amount of equipment on board of these vessels. It's really very costly assets. Okay, now we look at the future of the dredging industry. Future of the dredging industry is the economics of scale. Everything always becomes bigger and bigger. We see the cruise vessel there, Harmony of the Seas. This is one of the largest passenger ships in the world. Has a displacement of 120,000 tons and a length of 362 meters, maximum capacity of almost 7,000 passengers and 2,300 crews. These vessels require port infrastructure where they can go alongside. And there's many dredging projects that have taken place to make ports accessible to these huge cruise vessels. Below you see a picture of the Maersk Triple E vessels. There are 20 ships ordered. They have a capacity of 18,000, more than 18,000 containers, displacement of 55,000 tons empty, 400 meters in length. These vessels are requiring very big port infrastructures, not only for the dredging, but also the port, the cranes in the port need to be capable to discharge these vessels. Economics of scale also takes place in the dredging industry. In the 1990s, I was involved in the trailing suction hopper dredger Antigone, which had a hopper capacity of 8,460 cubic meters and was then considered one of the biggest in the world. And currently we have, as I explained before, dredgers of 46,000 cubic meters. So this is basically in a time span of 15 years that we went from 8,400 to 46,000 cubic meters. Another future is the renewables. Windmill installation, cable laying activities are done in Europe mainly by dredging contractors. What is very interesting is the picture you see here in the bottom. This is a concept, and it's called an energy island. It is a donut-shaped island. It's a man-made island. It is 3 kilometers in diameter, and it has a wall of 10 meters above sea level. During the night, when there is less electrical demand, the energy from the windmills will be used to drive pumps to fill up the basin of this energy island with water. When the demand for electricity is high, the water from this island will drive turbines and produce, for a time span of about 4 hours, 500 megawatts of electricity. That's basically the capacity of half a nuclear power plant. This is an investment of 1.5 billion euro and has an estimated operational cost of 6 million euro. There is currently a plan to build such an island in the coastline of Belgium. Another future for dredging, and this is also very new, and I believe this is going to be a big thing in the future, is deep sea mining. Deep sea mining is a process whereby minerals are extracted from the ocean floor. It's very comparable to what happened in the oil and gas industry. In the oil and gas industry, there was also, it started on the shore and it later went offshore. The same can be expected of mining. 70% of the Earth's surface is oceans, and the seabed contains a lot of minerals. Of course, currently they basically only search for rare materials, and that are mainly polymetallic nodules, which you see on the picture here. These are basically found in the Pacific Ocean at very depths up to 2,000 to 3,000 meters. So it becomes a very big challenge to extract them from the seabed. And another one are hydrothermal vents. These are basically underwater volcanoes that the funnels from this volcano, they break off after a while, and they contain valuable metals such as silver, gold, copper, manganese, cobalt, and zinc. There's currently a project ongoing, and the machine you see here in the bottom is developed for this project off the coast of Papua New Guinea, whereby they will try with this machine to get these thermal vents dredged and bring them to the surface at depths to 1,500 meters. This is done by Nautilus, a Canadian mining giant. And this project is going to start soon. This will be the very first deep sea mining project. Another future for the dredging industry maybe sounds strange, but it is global warming. Due to global warming, sea levels are rising at an alarming rate. If we look back in historical data from the 1880s, sea levels were rising with an average of 3 to 4 centimeters per century. After the 1880s, and that rose to 7.5 centimeters per century. And in the 20th century, we have an average of 14 centimeters of sea level rise. The record was shown in 1993 with a level rise of 30 centimeters per century over the last 2,000 years average. This will result eventually in some countries disappearing. One of them is the Maldives, which will be submerged if the water levels keep on rising. Many coastal communities are at risk. There is a National Geographic's video which you can find on YouTube, which is called Earth Underwater in the Next 20 Years. And there you will see simulated models of what can happen when the sea levels keep on rising as predicted. On that video, you will also see what is the role of civil works, dredging works that can be done to protect coastal areas. Now we look at the role of the marine surveyor in the dredging industry. The thing that you need to understand is that dredging is all about wear and tear. Because we are dredging very abrasive mediums by means of pumps, we have a lot of wear and tear. You see here an impeller from a pump that has been eaten up by the sand. We have a rule of thumb that states that 1 millimeter of steel is consumed for every 1 million cubic meters of sand that is dredged. When we have very big dredging projects, we form joint ventures. I showed you before the dredging project in Hong Kong, the dredging project in Dubai, and also the dredging project in the Suez Canal. These were joint ventures whereby different dredging companies will work together to complete the project within a certain time frame. Now, if these companies are going to work in a joint venture and they form this strategic alliance, they have to find a way, and they will sit down together and they will make a rule book. That's the rule book of the joint venture. And every vessel will have an in and an out survey. And for these in and out surveys, independent surveyors will be appointed. These surveyors will basically focus themselves on wear and tear. Pumps, cutters, drag heads, pipelines, both on board and on the shore, will be measured by an independent surveyor, which is appointed by the joint venture, and will be assessing the wear and tear of the equipment based on the agreed rules of the joint venture. And he will also put a price on it. This is done by ultrasonic thickness measurements, whereby the different parts are measured and inventorized, and all the wear and tear consumables are recorded in the in and out survey. So there will be a survey at the beginning of the project and a survey at the end of the project. All these reports will then be used to make a financial settlement in the joint venture project. This is really a very specific type of surveyor, and there are only a few companies in the world. Van Woerkom is one of the big ones, who have really specialized in this type of in and out survey for dredging vessels, and once again with a specific focus on to the wear and tear, I have some information here. These are some websites you can visit. Manufacturer of dredging equipment. There are basically 3 manufacturers. That is IHC, Vosta LMG, and Damen. These are the Boeings and the Airbuses from the dredging industry. We have the fantastic 4, Boskalis, Deme, Jan de Nul, and Van Oort. If you visit their website, you can go to their fleets and you can see all the different type of dredges they have. There are 3 important associations for the dredging industry. That is IADC, that is the International Association of Dredging Contractors, CIDA, which is the Central Dredging Association, and EUDA, which is the European Dredging Association. Okay, this is basically the end of my presentation. If there are any questions.
Luc, I suppose just a general point, really. A fantastic presentation, by the way. I thought that was absolutely first class. Can I ask you what sort of skills as a surveyor you are going to need to go out and assess and inspect one of these vessels?
Mainly it is non-destructive testing. You will do ultrasonic measurements of thicknesses of pipes, pumps, impellers. So it is a good knowledge of NDT, non-destructive testing, and gathering all that data and put it in a report.
Thank you. Stony silence. Everybody happy?
Yeah, no, it's Guy here. I've actually carried out 3 CMID inspections on the trailing suction hopper dredgers. Basically, some of the larger contractors now are using the CMID as a sort of playing field, a level where their vessels can be assessed on bigger projects, especially offshore-related projects. So, although I'm not looking at the NDT side of it and the specific dredging aspects, it's more of a vessel safety management and safety regime that we're looking at. But this is something which I think will come more and more as well with the dredging fleet, especially used in offshore projects.
No, that's correct. We have a lot of OVID inspections also when we go to projects in Australia. Which are mainly the gas development projects in the north of Australia. We go there with our dredgers. They are our clients, which is, for example, Chevron, they will require us to have an OVID inspection done on the vessels, and this is sometimes a bit difficult because these inspections are very specific to oil and gas vessels, and dredger is sometimes a bit difficult. So there are sometimes a bit of a gray zones, but so far we have always been okay with it. But it's correct; it happens more and more. Yes.
Yes, Howard St. John here. You haven't got my photograph because for some reason I can't turn my webcam on. But yes, I agree with you. I've done quite a few OVID inspections and suitability and CMIDs on all of the dredges, or several of the dredges in your big four.
Mm-hmm.
We worked it out.
Yeah,
and, very successful, really, and very impressive too. The last one I saw was something Magalhaes cutter suction, which was brand new, and it was in Korea, which was a very good inspection. I really enjoyed that one.
Okay.
I'm a South Coast dredger person myself. You know, it's good to see the new stuff come on.
Yeah, the big ones are really very, very interesting vessels. Technically, they are very challenging vessels.
Yes, and as you say, they're fully equipped ships. I mean, they're foreign going and everything, and that part of it's difficult. And also, I was very impressed with the logistics of it all, and certification for them was centralized, everything computerized, all held in head office. If you wanted to see something, you just asked them. Within 30 minutes, you got the document in your hand. I was very impressed with the system, most efficient, and they made my life really easy doing the OVID and the suitability. Very good.
These vessels have enormous.
Yeah, I've had similar experiences with it, as you say, the big four.
These vessels are very. I explained the asset values of these vessels, so the day rates of these vessels are very high, and the level of maintenance is quite high because the efficiency of these dredgers. These vessels have efficiencies. Trailing suction hopper dredgers have efficiencies to 96–98% efficiency. Cutter section dredgers close to 90% efficiency. So we get a very high efficiency out of these dredgers. So in order to do that, we need an enormous amount of spare parts. We need highly skilled people because the technologies on board is various. A lot of hydraulics, electronics, automatization. These are floating factories, basically. Yeah.
Yes, that's what I saw. Very good. Although the downside of all that is that, like the Magalhaes was, I think it was 10 months without work, which that probably is happening at the moment in a lot of places.
Yeah, there's a lot of dredgers idle for the moment. There are no big infrastructure works, basically all smaller projects. So, yeah, indeed, many vessels are idle for the time being.
There's quite a few marine surveyors idle as well, unfortunately.
Yeah, I think the whole marine industry, I think. Yeah.
Howard, it's Mike Schwartz. Yes, I know it's a tricky time for you commercial guys. For what it's worth, the small craft surveyors seem to be doing quite okay. But you fellas at the harsher end, I know, having a tough time.
Well, I suppose so, because if you're not working, you might as well go sailing or something, you know.
Sounds fun, doesn't it? Luc, can I ask you to end the recording, please, Luc?
Okay. Okay, I stopped it.
Fantastic. I just wanted to ask the other guys who are online. I mean, this is only the second one of these online seminars we've done. What do you guys think about the technology?
Very good. I'm having trouble getting I can't switch on my webcam because it's you can do it on Skype and stuff, but now I've got to download a driver to actually put the camera on.
Okay, it's the first time I've encountered that one, but you're coming across loud and clear.
Yes.
So
just a mistake on my part. I should have known. I did work before, but you need something else to switch on the camera for some reason.
Okay, and then what we will do once Luc has made the video later, we'll get that video sent back to you probably early next week sometime.
Yeah, that's fine.
So, brilliant. And then I've got a copy of Luc's presentation as well, which I'll also send over to you. And we'll even
sorry.
No, I was going to say we'll send you a certificate of attendance as well. So
we'll get 1 point then. CPD points.
Yes, you get CPD points as well. And whilst I have a captive audience of not very many here, we launched a CPD app, which you may or may not be aware of, just a week ago. And if you've not seen notification of that yet, you can now just download the app, which is either there's an Android version, an iOS version, and also just an ordinary web-based version. And you just go online now, you just claim your points. This seminar will be up there on the drop-down list. You claim your points, you get your 3 points, send them in, and Cam and or Jan in the office will accept your request. And those are credited then to your CPD account. So
marvelous. Nobody's really progressing very much because there's not much work, as you say.
Yeah, yeah.
Impressive talk, and no, very good. Happy.
Thank you, guys.
No, thank you very much.
Okay, thank you.
Brilliant.
Yeah.
Well, I wish you all the best. Thank you very much, Luc. Luc, if you can pop the video over when it's cooked itself and made itself, that'll be wonderful. And good to see you guys, and I wish you all the best and have a good weekend.
Okay.
Yeah, thank you very much.
Okay, and Luc, if you could end the meeting, that'd be great.
Okay, thank you.
All the best, fellas. Hope to see you again soon.